let's find out where my aircraft is now. You're flying an airway with a center line. So we discussed last day that airway could be defined using NDBs, it could be defined using VORs, and here the airway is defined using the center line of the airway. And we also saw the airway has a center line because the airway also has a 5 nautical mile buffer on both sides. So in NDB we have studied that. So the airway is just like your center line of the road or runway. The runway still is there on both sides and you have a center line. Yes, that is defined by, that's where you're flying an airway with a center line QDM of 137 degrees magnetic. So this is question number 8. So what is a QDM? What is QDM? It is a magnetic track to the station. So now our question, the station is a VOR DME co-location here. And what is the value of QDM? 137 degrees magnetic. So you're flying an airway with a center line QDM of 137 degrees towards VOR DME, which means you're moving towards the station. So don't try to skip any of these words in the question because they could be actually a source of information. Right? Now, here let's
But if it says QDM, sir, we are always towards the station.
No. Oh, no. Oh, I'm glad that you asked the question.
It's track to the station.
It is simply the track to the station. The track of the aircraft could be different. You see, for example, the aircraft is moving in that direction. And say, for example, I have an RMI. The RMI tuned to this particular VOR will indicate a QDM. That is simply track towards the station. That does not mean that the track of the aircraft is QDM. The track of the aircraft becomes a QDM when the aircraft is tracking towards the station. If the aircraft is tracking towards the station, then the track of the aircraft and the QDM will be same. Otherwise, it need not be the same. Right? Alright? Yes. So, here what is the track towards the station? Here the aircraft is also tracking towards the station and the QDM is 137. Right? Therefore, what is the QDM towards the station? That is 137. So, what is the RMI reading?
RMI
reads 141.
Reads 141.
Right? So it in line. So this is the QDM, which is 137 degrees. Let me kind of draw the VOR here. This is how VOR looks like. NDB notes circles. This is how VOR looks like. And in this case, the VOR is associated with a distance measuring equipment or a DME. Therefore, that is represented like this. So this indicates a VOR DME association. And what is the name of the station? It's A. That's given there. VOR DME A. Right? Now, where will I place the aircraft? On a QDM of 137, should I place the aircraft to the left or right of the station? Since the aircraft is coming towards the station on this particular QDM. Sorry. Yes. So where will I place the aircraft? To understand where the aircraft is
not. Yeah.
I have to look at the RMI reading.
To left of.
Yeah. So look at the RMI reading there. RMI is showing 141 degrees magnetic. That is the radio magnetic indicator is showing 145 degrees magnetic. Remember, because we have studied VOR, there are 3 indications for VOR. For NDB, we have 2 indications, RBI or RMI. In case of VOR, we have 3 indications, RMI, CDI and HSI. So RMI is also an indication for VOR in the cockpit. And that is showing you 141. This is the actual value read from the cockpit. This tells you that the track towards the station for you is 141 degrees. This is the track towards the station defined by the airway. And this is the airway center line. The aircraft could be anywhere, and the RMI in the aircraft is now tuned to the VOR. You put the VOR frequency, and that tunes the RMI into the VOR. And the RMI is telling you that the VOR is on a track of 141 degrees magnetic. Therefore, what is RMI indicating? RMI always indicates the QDM from the aircraft. So what is the QDM from the aircraft? Is 141. Let's draw a QDM of 141. This is 137. So how will you draw a QDM of 141? Correct? It's on this side. Right? This is a QDM of 141 degrees. Now, where will you find the aircraft? You have to find the aircraft on this line. And where will you place it? I have to place it here because the aircraft is coming towards the station. If it is here, the aircraft will not be having an RMI of 141. The RMI will be opposite to that because it will be pointing towards in this direction. We have seen that in VOR. So the aircraft is somewhere here. Now in this question, you're not really bothered about heading, drift, etc. It is not mentioned here, and for that reason I'm not considering any sort of drift, and therefore I take heading is equal to track here, and I place the aircraft. Now to understand the RMI indication, draw the dial. The arrow is going to point towards the VOR, and that is indicating 141 degrees magnetic. So you see, the aircraft is supposed to be within this airway center line, but the aircraft is off by a certain distance. You are asked to find out in the first question, are you left or right of center line? So what do you think? Are you left or right? I'm left of center line. Remember, it depends upon where you place the aircraft. If you go wrong on placement, this answer will go wrong. Next one, what is your distance off the airway center line? So you're asked to find out what is the distance of this airway center line, this distance here. Now, with such questions, you know how to approach. It's just a pure 1 in 60 question. But before applying 1 in 60, you have to see whether the angle is less than 20.
20.
So what is the angle here? 141, 137. Therefore, it is 4 degrees. More like a closing angle here, right? So if when I apply 1 in 60 here, closing angle is equal to distance off divided by distance to go into 60. What is the closing angle? Closing angle is 4 degrees. Distance off is asked the question. What is the distance to go?
Distance to go 90.
This is where DME comes into picture. The distance measuring equipment will tell you how far you are if tuned into it. So you can see it is going to show you this distance, the slant range here, right? Which is how much? Which is 90 nautical miles. But since this angle is small enough, I can take this distance also as 90. That is one of the approximations that we do with 1 in 60. Therefore, distance to go is 90 nautical miles into 60. And therefore, what is distance of? 360 divided by 60, which is 6 nautical miles. Therefore, this distance is how much? 6 nautical miles. You're 6 nautical miles off track or off the center line to the left of it. Understood? And the last question, are you in trouble with ATC? And in brackets, they have given a point which we discussed last class. As far as being with an airway is concerned, an airway normally extends 5 nautical miles either side of center line. So if I look at this particular airway here, this airway is going to extend 5 nautical miles on either side of center line. We have seen this with NDB in the previous class. Do you remember? If you are within this 5 nautical mile buffer, you are considered to be within the airway. But if I'm supposed to come on this airway, and if I'm here, am I within 5 nautical miles? No, I am off by 6 nautical miles, which means I am out of the airway. Therefore, am I in trouble? Yes. If you're 8, it's just like you are asked to be on the road and you are on the grass, and you're doing a driving test or something. Of course, you're in trouble, right? The same way. Therefore, that's what's happening here. You are out of the airway limits, and for that reason, yes, you are in trouble. You're supposed to be within the airway.